This is the factoring video number 3. Alright, so we're on the third part here, factoring perfect square trinomials and binomials, aka factoring in quadratic form. Okay, so here's the deal. Sometimes we have a perfect square term in the front and a perfect square term in the back. Let me even go to something even easier, okay? How about, let me move this to the side. We all know that x squared minus 9, if I ask you to factor, well, that's simple. You're thinking what times what is the last number that if you add together is the middle number, and you know that there is no middle number. In other words, what times what gives you negative 9 that if you combine gives you nothing. And we know that the answer is a positive 3 and a negative 3. Okay. So factoring, you're thinking what times what is the c value that if you combine together is the b value, and if there's no middle value, then you know you want it to eliminate. So it's positive 3 times a negative 3. Now, there's another way of looking at this problem. Another way is to recognize that this is a perfect square term. There's also another perfect square term. Okay, so because I know that this is a perfect square and this is a perfect square and there is no middle term, I could attempt to set up the answer, the parentheses, and say, okay, actually I shouldn't have done that. Let me give you the train of thought here, the other way of doing it. If you look at your perfect square term that's right here on the left side, you think, if I were to take the square root, right? If I were to take the square root of x squared, what does that give me? It gives me x. If I were to take the square root of 9, what does that give me? It gives me 3. So we know that this answer, if you did the square root, would be x, and you write that right here. And you know that if you took this answer and you took the square root, or that number, and you took the square root, that would give you 3. So x and 3 are going to be the pieces of your answer. So you could put an x right here and a 3 right here also. And because there is no middle term, you know that they have to cancel out plus or minus, because or plus and minus, because they have to cancel out. So obviously, if I had a question like this, I would just set this up and say, okay, what times what is negative 9 that if I add together is 0, right? And of course I would do it with this format, thinking, okay, positive 3 times a negative 3, and that cancels out the middle term. But when you have perfect square terms, like, get that factor out of the way. When you have perfect square terms, you could do the square root. It'll be a lot easier. So for example, right here, 25x squared and 36. Both of those, let me zoom in a little more, both of those are perfect square terms. You have a perfect square term here and a perfect square term there. So what we do is take the square root of 25x squared, and what do we get? If we take the square root of 25x squared, that's 5x. If you take the square root of 36, that's 6. So guess what? When you set up your factored form answer, it's going to involve the 5x and the 6. Check it out. There's the 5x and there's the 6 that I was talking about. And of course, since there is no middle term in this original quadratic binomial, there is no middle term, you know that one has to be a positive, one has to be a negative. And that's just the way it works out. It doesn't always work out this way, but it's a great way to set it up and then verify it. Always check. In other words, always go through and say, okay, 5 times 5 is 25x squared. 5 times negative 6 is negative 30x. 6 times positive 5x is positive 30x, and 6 times 6 is negative 36. And of course, the negative 30x and the positive 30x cancels out, and we really do get that expression if we were to distribute. So we know we did it correctly. Let's look at this next one. We also have a perfect square term right here, and we have a perfect square term over here. And of course, if you did the square root of 25x squared, you get 5x, and if you do the square root of 36, you get 6. So let me just do it right below it here. I might as well set up the answer. We said a 5x and a 6. A 5x and a 6. Now in this case, we do have a middle value, so we don't want it to cancel out. In other words, I don't want plus and minus because that would cancel out the middle term if I were to distribute. So let's think about it this way. This is a negative term in the middle, and the only way to get a positive 36 is if it were either plus plus or negative 6 times negative 6. Obviously, it'll be a negative 6 times a negative 6. Why? Because when you do the math, that middle term will end up being a negative 60. So I hope this kind of helps. Let's look at the top of this next page. Continuing on right here. And again, it says, just because you have a perfect square term as your first and last term, it does not mean that it will automatically work. So in other words, we need to check, we need to verify. Down here we didn't quite verify this. Let me verify it really quick. 5 times 5 is 25 with an x squared. 5 times negative 6 is negative 30x. Negative 6 times 5 is another negative 30x. And negative 6 times negative 6 is positive 36. Now I noticed a lot of people made mistakes when they combine these two middle terms. You're not multiplying anymore, now you're combining. It's like owing $30 and owing another 30. Well, yeah, you're going to owe 60 of those dollars, owe 60 x's. So we verified that it's 25x squared minus 60x plus 36. And there it is, 25x squared minus 60x plus 36. Let's go back to these examples up here. It says you have to verify because it doesn't always work. Just because you have a perfect square number here and a perfect square number there, it doesn't mean it's going to work. Let's try it out here. 4x squared, if you take the square root of that, it's going to be 2x. So I know that's going to be involved in our answer. And if you do the square root of 81, that's 9. And once again, 2x and 9. Now let's think about the symbols here. How could you get a positive 81? It's either going to be positive 9 times positive 9 or negative 9 times negative 9. Okay, so since the middle term is negative, I know that it's going to be a negative 9 times a negative 9. Let's verify quickly. If I did go 2x times 2x, I get 4x squared. If I go 2x times negative 9, I get the negative 18x. If I go negative 9 times 2, I get negative 18x again. If I go negative 9 times negative 9, I get positive 81. And of course, these middle terms really do combine together to give me the minus 36x. So I do know that this is the correct factored form, the binomial 2x minus 9 times 2x minus 9, which, by the way, it could be written like this. 2x minus 9 parenthesis squared. Either answer is perfect, whatever you want. Moving on to the next one. We do have a perfect squared term in the front. The square root of 9x squared will be 3x. Perfect square term in the back. The square root of 4 is 2. So my answer is going to be 3x with the 2. 3x with a 2. And now let's think about the signs. How could I get a positive 4 at the very end? It's either going to be a positive 2 times a positive 2 or a negative 2 times a negative 2. Now because the middle term is negative, I'm going to put negatives right there. Negative 2 times negative 2 gives me positive 4. Now let's verify and make sure it actually works. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is negative 6x. Negative 2 times negative 2 is positive 4. If we combine the middle terms negative 6x and negative 6x, it really does give us that middle term up here, negative 12x. So I verified, I know that this factored form is correct. So that's my answer. Negative 3x minus 2, and of course you could write it 3x minus 2 squared. Over here, this last one. Okay, the first thing I would do is pull out whatever the GCF, and in this case you could pull out a 2. Pull out a 2, you'll end up with 4x squared minus 9, and now on the inside you have a perfect square term. So you will be able to take the square root of it, and you'll get 2x and 2x. Square root of 9 is 3 and 3. And of course one will be plus and one will be minus because there is no middle term. They have to cancel out. And of course don't forget to bring down that 2. So this is your final factored form. I would verify it, but I ran out of time. So I hope this helps.